Hello class, let's tackle our last lecture on causal inference. So, in order to establish causation, I want you to know some basic principles. The normal equation of a line is defined as y is equal to mx plus c, where y is the outcome variable. Where y is the outcome variable, the y is defined as the outcome variable, or the disease, or the dependent variable, or the response variable. Whereas x over here is defined as the predictor, or risk factors, or independent variable. Okay? And the m is the gradient or slope. C is the y-intercept. That's the portion of the graph which passes through the y-axis. That's the y-intercept. Okay? So if you have multiple linear regression, we want to establish causation or causal inference. So, like I said, the x are predictors. So x1, that's multiple linear regression. This one is a simple linear regression. So we have the relationship is between y and x. So that the most important relationship we want to establish is what occurs between y and x. So y is equal to mx1, mx2, mx3 plus b, or the b is represent our y-intercept here. So our outcome variable, which is the disease or mortality, is hypertension, whereas our predictors are the x variables. So we have x1, meaning smoking can cause hypertension. When you smoke, when x1 increases, it affects y, which is the outcome variable. So y will only change based on small changes in x. So y is dependent on x. That is why we say y is dependent variable. But x is independent because it doesn't depend on y or on m or on the y-intercept. X does not depend on anybody. It depends on itself. So smoking will depend on itself. Lack of exercise, which can cause hypertension, will depend on itself. High cholesterol level or hypercholesterolemia will also depend on itself. So these three risk factors are called predictors. They are also called independent variable because they don't depend on any other variable to exert their effect. So they are called predictors, risk factors, or independent variable. But the y is called outcome variable, or dependent variable, or response variable, because that is the disease status. That is what depends, because for you to get hypertension, which is the y, it depends on the amount of smoking you do, your sedentary life, and the level of cholesterol in your blood. That will cause you to have hypertension. So hypertension, which is the outcome, depends on x1, x2, and x3 for it to exert its action, or for it to become hypertension, or the outcome. So y is independent. Y is dependent on x1, x2, and x3. But x1, x2, and x3 don't depend on y. They depend on themselves. Smoking will depend on itself. Lack of exercise will depend on itself. Hypercholesterolemia will depend on itself. And all of them go to increase y. So an increase in x1, x2, and x3 will lead to increase in y. An increase in only x1 will still lead in increase in y. An increase in x2 will lead in increase in y. The same way, an increase in x over here, which is the sole risk factor over here, will cause an increase in the outcome variable, which is y. So when we come to plot a graph of this, we have the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. So changes in x will cause a change in y. So when smoking starts from day one, you smoke 1 cigarette, it will let you have 2 odds of hypertension. If you smoke 2 sticks of cigarette, it will increase your odds of getting hypertension. If you smoke 3 cigarettes, it will increase it to 6. If you smoke 7, it will increase it to 12. So changes in y is dependent on what? Changes in x, and x is the risk factor. So if you have high cholesterol level, it will let your hypertensive status to be very high, your cardiovascular disease status to be very high, and your myocardial infarction will be very serious. You will get stroke and heart attack at a go. And this shaded portion is the slope. And this is why we see that the y-intercept is passing through the origin. It didn't pass through the y-axis. So note this, because some of these aspects will be in the exams. So if you don't really understand, you can watch videos on it or ask me the questions that are baffling your mind. So this is linear regression, simple linear regression. That is an equation of a straight line, and this is multiple linear regression. And this has its implication also in the logistic regression. So we want to infer causation. So increase in the predictors will cause the disease status, which is hypertension. So this is causal inference. Thank you very much for staying tuned with me.